Eric Burgess here, and we've been asked to find the derivative of the natural log of sine x, and then this over e to the y. So this is one that's just kind of a chain rule bonanza, just things inside of things inside of things. So let's just start with the outermost layer and work our way in. So first we take the derivative of the function. So we're going to get y is equal to, and then the derivative of the natural log is 1 over x, right? So in this case, it's going to be 1 over all that stuff in here. So we're going to have the natural log of sine x over e to the y. But then we have to take a derivative of all this stuff on the bottom, right? We have to multiply it by that, the chain rule, the inside function. So doing that, we look inside and we say, okay, well here we could use a product rule or a quotient rule. I don't see any obvious advantage just looking at it to pick either one. And since it's already in quotient form, I'm just going to go with a quotient rule. So that would be high d low, so the derivative of the high times low. So that's going to be, the derivative of the high is again going to be 1 under sine x. And it's under sine x because it's 1 over x, right? But in this case it's sine x. But this itself requires a chain rule. This is going to be cosine x. So times cosine x. So that's the derivative of the high times the low, which would be times e to the y, minus low d high. And this has a definition of y in it. So we're going to need to take a y prime e to the y. So this is going to be an added bit of fun. I didn't realize that there was a y down there until just now. So we're going to have to somehow get this out of here. So we're going to have minus e to the y times the top, which would be the natural log of sine x, over the low squared. So e to the y times e to the y. And I write it out separate because e to the y appears everywhere. So we're able to just go ahead and simplify e to the y out. And we're left with this as the derivative. So let's just see, how much simpler we can make this, because this looks kind of like a mess, but this is what it is. So the first thing we can do is we can flip this fraction and write it on top so that we don't have a complex fraction. So we're going to have, and we took the derivative, so this is a y prime. So we're going to have e to the y. Oh, look at this. This e to the y will simplify with the other one quite nicely. Over the natural log of sine x times, and then on this one, just looking at this, well, let's just write out this monstrosity. So we can rewrite cosine x times sine x as cotangent x. So I'm going to go ahead and do that. Cotangent x minus, and we're going to have a y prime, the natural log of sine x times e to the y. So these e to the y's will simplify. We'll just do it one step at a time, try and avoid any mistakes. And we get y prime is equal to cotangent x minus y prime natural log of sine x all over natural log of sine x. This is where I am like sorely tempted to do mental math, but it can really bite you if you jump the gun. So what I'm going to do now is I'm going to multiply by, because our whole goal here is to get these y primes together so we can factor out the y prime and then divide out what remains. So I'm going to get rid of the denominator by multiplying it to both sides, and we'll wind up with y prime natural log of sine x equals cotangent x minus y prime natural log of sine x. And what this means is now that there's no denominator, we can go ahead and just add this to the other side. So we're going to get y prime natural log sine x plus y prime natural log sine x is equal to cotangent x. And from here, we could factor out the y prime. And in fact, we have two of these. So we're going to be winding up with y prime times 2 natural log sine x is equal to cotangent x. And then we can just divide this out. So we get y prime is equal to cotangent x over 2 natural log sine x. And that would be our derivative. So this one, and then we did this with the quotient rule. You could try the product rule. Might have been easier. I don't know. It's kind of tough to tell. But there you go. And it's actually, it's not actually that long after looking at it, but it does look pretty scary, and you've got to be on your toes about the chain rules that come up, because if you miss a chain rule, you're going to be out of luck later. I have a feeling this y prime here will get a lot of people, and I think most people would catch the chain rule here, the embedded chain rule. It's this y I think that would get people. But there you go. If you have any questions about this, feel free to drop them in the comments down below. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.